Electric current is the rate of flow charge carriers measured in amperes. When an electric charge, positive or negative, moves, we get electric current. Now, an electric charge moves through a conductor, which is a material that allows electric charge to flow through it easily. Here we have a copper wire. Now, when a conductor is connected to a power source, like a generator, the electric charge starts to move through the conductor. This is known as electric current. The greater the flow of charge, the greater the electric current. Now, the electric current typically flows from the positive terminal of the power source to the negative terminal. This is known as the conventional current. This is the opposite of the direction of electron flow, as electrons are negatively charged, so they flow away from the negative terminal of the power source to the positive terminal. Now, electric current can be represented by the following formula. I, measured in amperes, is equal to delta Q over delta T, delta Q being the change in charge measured in C, tells us how much charge has moved through a circuit during a certain period, and delta T, measured in seconds, is the time interval, which tells us the duration over which the charge has been flowing. Now, this formula can be summed up as: to find the electric current flowing through a circuit, divide the change in charge by the time it took for that change to happen.